At the end of this video you can learn how to recreate this simple pattern using Python Turtle. So, sit tight and open up your favorite IDE. Hello and welcome to this Python Turtle tutorial. In this video, we'll be covering the basics about downloading and using the Turtle module in Python. Whether you're a complete beginner or a seasoned programmer, this tutorial is for you. To get started with Turtle, you first need to download the Turtle library. So click on File, then Settings, and search for Python Interpreter. Click on +sign symbol, and search for Turtle. And then click on Install Package, and wait for it to download. Another method is downloading it through command prompt. So press your Windows key +R and hit Enter. And I want you to type pip install turtle, and press Enter. Wait for the installation to complete. And that's it. Turtle should now be installed on your computer. Now that we have Turtle installed, let's start using it in our Python programs. To use Turtle, we first need to import it into our program. With this line of code, we're telling Python to import the Turtle module into our program. Once we've imported Turtle, we can create a Turtle object that we'll use to draw on the screen by creating a new Turtle object called T. But if we run the program, you will see that our Turtle window will immediately close. To prevent that from happening, we will type turtle.done. This is a method in the Python Turtle module that tells the Turtle graphics window to wait for the user to close the window. So if we run the program again, you will see that our window will not automatically close. And you can see, the little black arrow in the middle is our turtle. We can give it a command like forward. This method takes a distance argument as input, which determines how far the turtle should move in the forward direction. When we run the program, the turtle will move forward at the distance that we put. In this case we put 100. Next is left. This method takes an angle argument as input, which determines how many degrees the turtle should turn to the left. When we run the program, you will see that the turtle turned left in 90 degrees, because that is what we put. So when we put forward again, the direction of the turtle will follow the angle that we set. Next is right. This method also takes an angle argument as input, which determines how many degrees the turtle should turn. But this time to the right. So when we put forward after it, the turtle will go forward in the right direction and depends on how much degrees we put in. Next is back. This method takes a distance argument as input, which determines how far the turtle should move in the backward direction. When we run the program, you will see that the turtle will go backwards. And now when you know all of it, you can now create a simple box shape using forward and left method. But as you notice, doing it manually takes a lot of time and lines. To save some time and lines, we can use a loop in our code. So, we can use a for loop to create a square much efficiently. To do that, we just need a for loop that iterates 4 times, because a square has 4 sides. Next, we will put a forward in 100 and left in 90 degrees angle, so that we can make a perfect square. If we run the program, it will draw the same square before. The next method I want to show is width. This method takes a numeric value as input, which represents the desired width of the pen in pixels. So when we run the program, you will notice that the line thickens depending on how much you input. Next method is Pencolor. This method takes one or more color arguments as input, which can be specified in a variety of ways. like by name, hexadecimal RGB value, or an RGB tuple of values. But for this example we used a name. Next is shape. This method takes a string as input, which specifies the name of the turtle shape, like turtle, circle, square, arrow, triangle, and classic. But for this example we use turtle. Next is speed. This method is used to set the speed of the turtle's movements on the screen. It takes one argument, which is an integer value between 0 and 10. As you can see, the higher the value, the faster the turtle moves. 10 is the maximum value of speed of a turtle. But if you want much faster, you can put 0. If you are confused, a value of 10 is the maximum speed, and the higher the value, the faster the turtle movements. A value of 1 is the slowest speed, and the turtle's movements are very slow and smooth. A value of 0 is a special case that represents the fastest possible speed without any visible delay between movements. Next is Hideturtle. This method is used to hide the turtle from view on the screen. When you call this method on a turtle object, the turtle's icon or shape is removed from the screen, but the turtle can still be used to draw shapes and lines. We can also create a circle by using the circle method. This method takes one or two arguments, which determine the radius of the circle and the extent of the circle to be drawn. If only one argument is provided, it specifies the radius of the circle. If two arguments are provided, the first argument specifies the radius of the circle, and the second argument specifies the extent of the circle to be drawn, in degrees. There is also a third argument in circle. This argument specifies the number of steps or turtle movements used to draw the circle. The number of steps determines the accuracy and smoothness of the circle. A higher number of steps will result in a smoother and more accurate circle, but will take longer to draw. A lower number of steps will result in a more jagged and less accurate circle, but will be faster to draw. For this example we use 3. So the tool draws a triangle because it has 3 sides. It can also make diamonds by putting each steps into 4. And now that you know the basics of Python Turtle, you can now recreate this simple pattern from the beginning. First, we need to create a forward line, and the triangle in the end. To do this, we can use the forward method and set the value to 50 to create a line, and then to make a triangle we will use the circle method. We can set the radius to 20, the extent to 360, and the number of steps to 3. And now we need the turtle to be back at the beginning, so we will use the back method. So, we can set it to 50, so that it can go back to its exact location. Now we will need to duplicate this exact line, so we will need to use the for loop. And we will use the left method that is set to 30 degrees angle to turn the turtle to the left by 30 degrees after each iteration of the loop. And now, we just need to extend the pattern. To do that, we will need another for loop. Next, we will create a variable that have a value of 50, the same as the value of our forward and back. After we set the variable, we can replace the 50s with x. And then we will put x plus equals 10, so that after the inner loop completes its 12 iterations, the value of x is incremented by 10. This increases the size of the pattern that will be drawn in the next iteration of the outer loop. This continues until the outer loop completes all 15 iterations, and the final pattern drawn will be larger than the initial pattern by a factor of 10 for each iteration of the outer loop. Next, we can speed up the process using the speed method that is set to 0, and we can change the color to red using Pencolor Method. And now, you successfully create your first pattern in Python Turtle. And that's it for the basics of Python Turtle. There are many more commands and functions you can use with Turtle, and we will tackle it in the next video. I hope you found this video helpful. Don't forget to like and subscribe for more Python tutorials, and I'll see you in the next one.